guys, I just want to go through the notes for section 10.3. This is the new book. The old book was still calling it 9.3, so we've kind of been floating back and forth between the two. If I give you the equation natural log of 1 plus x, and I tell you to find the Taylor series centered at x equals 0, and I want a fourth degree, which means x has to be to the fourth power. First, I start with my equation, and then I just keep finding derivatives until I get to the fourth one. That tells me how many derivatives I need as well. And then they say that it's centered at 0, so I have to plug in x equals 0 for each one. And then I plug everything into my Taylor equation, which is f of a plus the derivative times x minus the center to the first power divided by 1 factorial, minus the next derivative, the second derivative, second power, 2 squared, next derivative, third power, 3 factorial, fourth derivative, fourth power, 4 factorial. And when I clean it all up, this is what this looks like. Just remember that this is 3 times 2, so I can cancel out the 2's. This is 4 times 3 times 2, so I can cancel out the 6's. So the natural log of 1 plus x is beautiful. And on page 491 in the book that we use, they give you 7 of these ones that you're supposed to have memorized in a normal calculus course. Obviously, if we're at the end of the year, I'm not going to have you guys memorize these, but normally I would even test on those 7 to make sure that you know all of them, have them memorized. It would be able to tell me their general equation as well. Now, also on page 491, it tells me that this equation and the original problem, which was the natural log of 1 plus x, these two equations only look like each other from -1 to 1. And that's including at 1, but not including -1. So even if I were to put in 1,000 terms, it doesn't matter. The equations will only look like this from x equals -1 to 1. Okay, so now you will need to reference the equations on 491 later, but you'll have that in front of you. Now, one of the things we have to do is find error, and there's an equation called the LaGrange error method. And I'm probably going to have one of these on the quiz just to see who wrapped their head around it and who didn't. But it's not a horrible thing. It'll come back to haunt you, or it'll come to haunt you in your Calc 2 classes. So this is the general equation. So I wrote this out so that it's all pretty, but then I rewrote it down here and I messed it all up. Okay, so this m, do you remember back when we did trapezoid rule, the m stood for the maximum value of the second derivative? Well, when we're using Taylor series, m stands for the maximum value of the next derivative. So if we use 4 derivatives to create our series, we're going to use the max value of that 5th derivative, that one that I didn't even make you find over here. Then the a is our center, where the two equations start to look alike. If we're using a Maclaurin series, then a is going to be 0. That's the special Taylor series, centered at 0. The x will be given to you. It's a particular x value. And n plus 1 just represents the next one. So we said that this was the next derivative. This is the n plus 1 power. This is n plus 1. So these 3 things match. So let's do an example so that you can see what I mean. The series for cosine of x. I'm not going to make you figure it out now, but here's the series for cosine of x. It's one of the ones that you're supposed to have memorized. And if I use these first 4 terms to represent the sum, it means that my next derivative is the one I'm going to have an error, have a problem with. Okay, so if I only use 4 terms to represent a number for cosine of x, I'm going to be a little bit wrong. I'm not going to be exact, but I will be close. So in this case, since I am only using a few terms, remember that we have to be close to our center. Well, our center is 0 because all of these are x minus 0 squared. So our center is 0. So I'm going to pick, for my example, I'm actually going to pick cosine of 0.1. 0.1 is really close. Now, the good news about cosine and sine is that if I enter 1,000,000 terms, cosine will look like its series. Like the more terms you use, the more that everything spreads out to look like the original equation. So if I used a bunch of terms, I could have asked you to predict cosine of, 1,000,000, and it would give you the correct answer. So if I ask you to estimate cosine of 0.1, I write out the series for cosine of x, and wherever I see x, I'm going to put in 0.1, and that is what I get when I plugged it into my calculator. Now I'm going to use LaGrange to estimate my error. So here we go. I went up to the 6th power, so 7 is our key number for this problem. You will love sine and cosine whenever I ask you to find the Lagrange error, because no matter what derivative you take, there's only 4 things you can get, right? If I tell you to take the derivative of negative cosine, I'm going to get sine or cosine or negative sine or negative cosine. And if I ask you for the maximum value of any of these, you know that the answer is 4, or is 1. I almost said 4. Is 1. So that is always going to go, when I'm talking about sine and cosine, 1 will be what I put in for my m. Now, I told you that the equation was centered at 0, so a is 0. The x we were estimating was 0.1, n plus 1. Remember I said since we used to the 6th power, the next one is key, so that's the 7th. So I put 7 here and 7 factorial here. My n for the original problem was 6. So now we're dealing with 7. And when I plug that in my calculator, it is so close to 0. It's something, I think, e to the negative 13 or something like that. But it was so close to 0, it's not even worth saying that it's not 0. So we're so close to the original answer when we use the series instead. Now I want to give you a little math Excel help. You're going to have to do things like rewrite e to the negative 8x. We did this in class yesterday. So all you have to do is write out the series for e to the x. You can use page 491. I will have that available for you when you're quizzing. And then wherever you see x, you're going to put in negative 8x instead into the series. Same thing with this one. You're going to have, again, these are all examples. Not everybody has the same problems, but cosine of negative x times 9, you write out the series for cosine of x, and then wherever you see x, you put in negative x, and then you multiply every term by 9. For this one, you write out the series for cosine of x, and then you multiply every one of those terms by 6x. Now this one's a little bit harder. You have to write out the series for e to the x, and I even wrote it out twice just so you can see what we're going to do. So since I'm squaring it, I'm going to have to multiply 1 by each one of these terms. So I'm going to have 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus x to the 4th over 4 factorial plus, now I have to multiply x by each of these terms. X plus x squared plus x cubed over 2 factorial plus x to the 4th over 3 factorial plus x to the 5th over 4 factorial. Now they'll tell you, they will never just have you write one of these out without giving you how many they want. So they may say to the 4th power. So after you multiply this by everything, this by everything, this by everything, what you're going to do is combine all of the like terms, everything that's that has an x to the 4th. You're going to combine those, and you'll come up with an equation that way. For this one, 5x cubed over 1 minus 5x, one very similar in the homework. You're going to write out the series that's on page 491 for 1 over 1 minus x. Then wherever you see x, you're going to put in 5x. And then you are going to multiply this series, every term, by 5x cubed. Now, one of the more difficult looking questions, but isn't really hard, is they're going to ask you, this wording looks hideous, right? But all they're saying is, write out a series for sine of x, and how many terms do I need so that if I write out the first 2 terms for sine of x, and I subtract the original equation, because that's going to tell me my error, right? Like how wrong am I if I use the series instead of the original equation? And they give me endpoints, and you're always going to be most wrong at the endpoints. So you're going to plug in these two values into this equation. Oh, that tells me my time is wrapping up. And you're going to see if you get a number less than 0.01. If you don't, then you need to start the whole process over and plug in another term. And you need to keep doing that until you get a number less than 0.01, and that's going to be your answer. Finally, they give you a hyperbolic. So I say finally, but there's one more. If they give you a hyperbolic, who cares that it has a name? They tell you that cosh equals e to the x plus e to the negative x divided by 2. So write out the series for e to the x. Wherever you see x, put in negative x. Add these two together and divide by 2. I made up this series. I know that here is your regular Taylor series. They like to ask the question saying, so find the second derivative. There, they tell me up here, find the second derivative at 2. Well, I know that this has to line up with this. Actually, it should be negative. Has to line up with this because these both have the squared terms. So I set them equal to each other. And when I do that, I solve for my f double prime of 2. I can ignore this on both sides, and I get f double prime of 2 is 5.